Here we'll do one more example of a composite function, except for this time, rather than f composite g at x, we are asked to find f composite g at 8, which is a number. When you have a number inside that parentheses, we're going to do things a little bit differently. Previously, we had x inside, and in that case, we started with the first function, and that was f in this case. However, when we have a number inside, we go in reverse. We start with the second function instead, similar to if we were doing a domain problem. The second function here is g, so we're actually going to start with g first rather than f. So we'll begin by finding g at 8, which is the piece that I've boxed in. So we'll have square root of 8 minus 4. If we take 8 minus 4, we'll get square root of 4, and square root of 4 is equal to 2. That's our answer to g at 8. Now we're going to use that answer of 2 and go back to our first function. Our first function was our f, and so we'll start by writing f of something. But now we're going to pass in our answer from g8 into that new f. So we're taking our answer from our second function and passing it back to our first function. So now we're trying to find f at 2. For f at 2, we'll take 2 times 2 minus 3. 2 times 2 is 4, minus 3 gives us 1. This will be our answer for this composite function. Notice that I've started by evaluating the second function, g8, before I go back to the first. The reason why I do that is to make sure that the function exists. If we plugged a number into that square root and ended up getting an imaginary answer, we would have to say d in e. Anytime you're doing composite functions and you get either an imaginary answer or a function that's undefined, we stop and we say d and e immediately and we don't go any further. This is why we start by doing the second letter before we try to deal with the first.